Hello from West Virginia. Or someplace. But let's take a look at joke of the day because I know that you're ready. I know that you're waiting and I've got a good one for you. So all you coffee drinkers out there, what coffee do people drink when they're sad? What coffee do people drink when they're sad? Depresso. Like espresso, but it's depresso. Well, what's not depressing is the product rule for logarithms. And what the product rule for logarithms does is it allows us to simplify logarithms. The product rule for logarithms says when you've got a product and you are taking the log of that product. Now notice here that it says B, M, and N are all real numbers, not complex numbers. We now know what complex numbers are. And so we've got real numbers. B is not going to be a 1. So in other words, the logarithm down here is going to be anything other than a 1. Notice that fractions, decimals, negatives, everything's okay, even irrational numbers, but what's not okay is a complex numbers. So now that that's clarified, what's going to happen here is when we have a product and we're taking the log of the product, we can take the product and we can split it up. And we can take the log of the first factor, take the log of the second factor, and we can add those two logarithms up. Now this should be fairly easy to memorize because it's very similar to our product rule for our laws of exponents. Remember we said that when we were multiplying bases and the bases were the same, we added the exponents. Similar concept here because when you're doing log, it's say you have a base down here. So it's log of the base, so it's kind of the same idea. The multiplication kind of goes with addition. So when you're multiplying bases, add the exponents. When you're multiplying your factor there, then you're going to add the individual logarithms. This also applies to common logs, which remember is log base 10. It also applies to natural logs, which is log base e. Remember, when you have a base e down here, we shortcut it to be a lowercase script ln. So let's take some examples of using this product rule in order to be able to expand our logarithmic expressions. So notice we have log base 8 of the product 13 times 7. That's not 13.7. It's not a decimal. It's 13 times 7. So if we're going to expand this logarithm according to our product rule that we see right here, what happens is we take the log of the first factor, we take the log of the second factor, and we add the two logarithms together. This is the expanded version of that logarithm. So let's try one more just to make sure we're really good at it. Notice here that there doesn't appear to be a base. When it doesn't appear that there's a base, what is the understood base? Yes, it is a 10. So I have an understood base of 10 right here. And once again, my product rule for logarithms says, okay, I can take the log, and I'm not going to write the 10. It's still going to be understood. I'm going to take the log of the first factor, 10,000. I'm going to take the log of the second factor, x. And again, I'm not going to write my base of 10, and I'm going to add the two together. Now, I can do log base 10 of 10,000. Remember, what log base 10 of 10,000 actually means is, and I'm going to write it separately over here. Remember, if in order to evaluate that, what we do is we say base to the outside power equals a number on the inside. My base is understood to be a 10. To this power equals the number on the inside. Well, what power, in other words, 10 times 10 times, how many times would I have to multiply 10 by itself to create a 10,000? Well, 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. So 4 is going to be my power here. And so that means that this log base 10 of 10,000 is actually going to be a 4. So I have 4 plus log of x. And there it is in expanded form. Now we can also use our product rule of logarithms, logarithms in order to take something that is expanded and condense it. So take a look at this little very small chart that I've got to help illustrate this. And what it says is, here is that product rule that said if I have numbers that are multiplied together, factors that are multiplied together, and I'm taking the log of that product, I can split the logs up, do the log of the first factor, log of the second factor, and I can add the 2 up. That is expanding it, because notice it's making it a much bigger mathematical sentence. Or I can take what is already expanded and I can condense it. So if I have 2 logs that are separated and they're put together by addition, notice though, same base. Very important that they have the same base. If they do have the same base, then I can condense it and say I'm going to put it under one base, and I'm going to multiply these 2 factors together. So let's take a look at a couple of examples of that. We're going to condense each of these logarithmic expressions. We're going to write the expression as a simple logarithm whose coefficient is a 1. So take a look at this first one. Notice it says natural log of x. What's the understood base? Yes, an understood base of e, which we don't have to write. Plus natural logarithm of e, again understood base of e. They have the same base because they are both natural logarithms. So what I can do is I can condense it into 1, and I can say, okay, I'm going to take one of these natural logarithms with that base e. Because it's addition, I'm going to multiply these 2 factors together, 3x, and that is now condensed. There is nothing more that I can do with this, as opposed to the previous example. Let me flip back to that for just a quick second here. Notice this one, I did take that further because I can figure out what log base 10 of 10,000 is. Here I couldn't do that any further because I don't know what 8 to a particular power is going to give me a 13. There's nothing that I cannot multiply 8 by itself a certain number of times in order to create a 13. So this cannot be evaluated. As well here, I can't figure out 8 times itself how many times to create a 7. That's not going to happen. So therefore, I cannot evaluate this. I cannot evaluate this. I am stuck, and this is expanded as best I can expand it. This one I could take it a step further because I could figure out what log base 10 of 10,000 is. Similar idea is going to happen here because I'm not really sure what I can take e to what power to create a 3x, so I'm not going to be able to create a 3x. So this is condensed as best as it's going to get. So let's take a look at this last example. I have log base, no, it doesn't look like it's there. Yes, it's a 10. Another log base 10 here, so we're good to go on each, having the same base. When the base is the same, we can put them together. It is addition, so we can take this factor and this factor, and we can multiply the 2 factors together. So I'm going to have one logarithm, that base 10. I'm going to multiply the numbers together, 250 times 4. Well, what is 250 times 4? That's 1,000. So I have log base 10 of 1,000, and aha, remember I can go, let me write it over here, and I'm going to change colors so we don't confuse ourselves. Log base 10 of 1,000 is going to mean what base, that's 10, to the outside power, so 10 to the x, will give me the number on the inside. And now I ask myself, 10 times, how many times will I multiply 10 by itself to create 1,000? Well, 10 times 10 is 100, 100 times 10 is 1,000, aha. My exponent here is going to be a 3. So therefore, log base 10 of 1,000 is just a 3, and that's it. I can take that a step further because I can evaluate that logarithm. So hopefully this helps you to understand the product rule for logarithms and how helpful it is for being able to expand your logarithms and for being able to condense your logarithms. All of it is about simplifying logarithms. And remember, easy to remember because it goes back to the similar idea that we had whenever we were looking at our laws of exponents. Multiply will equate to, or will liken to, will lead to, there's a better word, will lead, multiplication will lead to addition. Because you're going to see something different when we look at the next video where we're going to look at the quotient rule for logarithms and how it likens to those laws of exponents. I hope that helps. Have a great day.